So in this video, I'll talk about quantity takeoff for formwork, concrete, and rebars. So first thing you need to do is to make sure you go through my assumptions, because I do have extra information you need in my assumptions. For example, the size of the, garage door, right? The check size on foundation wall for garage door, it's 2520 by 300 millimeter depths at both, say, garage door opening. See, I have this, right? I also tell you what is the recess on the foundation wall and porch slab is 100 millimeter by 125, right? I tell you, you see, what is the recess? Say the recess of the foundation wall at the sunken laundry area is 100 millimeter by 300 and 330. So 100 millimeter is the width, 330 it's a depth. So also I say bottom of the basement window frame sits on 125 millimeters below the top of the foundation wall. Okay, you see top of the foundation wall to the finished grade, existing grade is 200 millimeters. So those are I gave you the size, right? Then you see the size for the steps, right? Step footing. And some other things, you see the size for the partition wall footing next to the column footing, right? And then also rebar, you see, I say assume 10 M rebars at 300 millimeter on center, both way in porch slab. The concrete cover is 50 millimeter. So those are the information you need to read, okay, before you go through the drawings. So after we did our excavation calculation, we already know the drawing, right? We are already familiar with the drawings. Now we are going to look at the formwork first. So when I go through this, I'll talk about formwork and concrete together. I think that will be better. So you see, look at the formwork first. We have, this case, right? If we look at 3D drawing, we have this foundation footing, right? Foundation wall, column footing, right? And we have a recess on top of the foundation wall for the windows, garage doors, right? Those are the, places we need to think about from the edges, right? And also formwork for the slabs. Understand, right? We have special formwork for the step footings. The step footing goes there, right? How we consider that? Okay. For the regular footing, and we know the depth of the foundation wall footing is 155, and the depth of the partition wall footing is 150. So both of them are smaller than 200 millimeters. So that means we are going to measure the formwork for the foundation wall footings by the lengths. So if you look at my recap, the first item is formwork to foundation footing, right? Foundation wall footing, I should say. So that's, the depths, 150, 155, they have the similar unit price. So we can put them together, right? We measure them by the lengths. So basically, what we need to think is take the length of the footing, right? Then multiply by 2, right? Center line length of the footing multiply by 2, get 2 sides, right? So what what is the best way to do the quantity takeoff in this case? I would recommend you to calculate the length of the wall, which is the length of the footing, for the basement first. See my cursor goes. Take the perimeter center line for basement foundation wall. Okay, because you are going to reuse that length of the wall for footing and for foundation wall. If you pay attention to the drawing, you see the depth of the foundation wall for basement. This is different with the depth of the foundation wall for wall to the cold cellar and the depth of the foundation wall to the garage. You see, garage is, easily we found that out, right? So that's why we separate them. Because when we calculate the formwork for foundation wall, we are going to use the length again, right? Concrete for foundation wall, we are going to use the length multiplied by height, right? Multiplied by thickness, we get the volume. If we want to get the formwork, we take the, and if it's for foundation wall, we would take the length of the foundation wall multiplied by height, multiplied by 2, get both sides. You guys remember that, right? That's why, okay, we're going to take the perimeter of the basement foundation wall, then plus the length of this wall. Here, cold cellar, plus the length of this wall. Okay, I should say plus the length of this footing and this length of this footing. Well, we are looking at the formwork for footing, right? Get that, multiply by 2. We get both sides. Okay, so we need to think about if we have a step footing like this, what we need to do for step footing. If we look at the help sketch, you see, if I look at the footing, you see the footing here, right? That's my footing. The length, if I just take the total length, I multiply by 2. That will give me this length and this length, this length. But I need to pay attention to here. So the formwork is different, the size, because we need to take extra material, right? Also extra labor to do this, to cut the shape like this, right? So this part of the formwork for the footing, it's more expensive than the formwork this side. For example, this formwork here, it's around, let's say, $15 per meter, okay, or $20 per meter. But here, right, would be $20 or $25 per meter around here. So I need to separate them. So what I do here, right, for this wall, I will take the length of the footing, right, from here to here, right, the length of the footing. I'm looking at footing first, okay. Length of the footing, I need to subtract this length here, right? Then I subtract this length would be here, right? And another side would be there. Understand that, right? Because there is one step footing this side, another step footing this. I'm going to take this length, subtract 1200 this side, another 1200 this side. Then I multiply by 2. I will be able to, get the length of this part, right? This part. After that, but add to other footing, the length of the other footing, because they are same, right? After that, I'm going to calculate this separately. So this footing here, if I highlight that, okay, that footing, I have one piece around here. Either, right? It's footing. We're talking about footing. One is this, right? I have another one. This side, step footing. Around here, right? So now you need, you need to think about, if I calculate this, the length of this form, how many pieces? Think about one side, another one side, another one side here, one side there, right? Understand that? So that will be 4 pieces of this. That's our item number 2. So formwork to step foundation footing sides. That's this. That's this part. That's this part here. If I draw it under foundation plan, it's here, here, and this side, this line there. Okay. So in this way, we can price them separately. You know, one price for this formwork for this kind of foundation wall footing, right? Another one is, price is for unit price for, formwork for the foundation footing like this, foundation wall footings like this. Okay, that's the number 1 and number 2. Number 3, you say formwork to step foundation riser. 518 millimeter high. That's here. That's right here. Right here. If you look at the 3D drawing, I think I have a 3D. Say that's this piece. You say if you do, if we just look at the footing, right? The step footing goes this way, right? How we build this step footing? Other than the sides, right? We need to put the formwork at both sides. We also need to put formwork here. Let's draw that. That will be. Understand this? So the area of this would be the width of the footing, 480, multiplied by height of this, formwork, 580. You get this area for one piece, right? Step footing, each step footing, we have 2 pieces. We have 2 step footings here, right? That means we have 4 pieces, right? For both sides. So that will give you, add 4 pieces together, that will give you the total area for the, step foundation, step footing riser, okay? Or to step foundation riser. Okay, formwork to column footings. We have column footings, 3 column footings there, right? If we look at this. The formwork for column footings would be 4 sides, right? Around the sides. What you do is take the perimeter of this, multiply by the depths, you get the formwork area for 4 sides, right? Around. That's what you need to pay attention to. That's easy, right? Okay, now the formwork to foundation wall. Okay, now we see. Formwork to foundation wall, like I said, we say this foundation wall, this goes around for the basement. Once that's, we can find what's the depth of that, right? We take the length, perimeter center line length, multiply by height. So if I draw that, we do the analysis, right? You see, we have this dimension here, right? We take this dimension, we subtract this dimension, we need to add 200. I give to you this dimension. We get top of the foundation wall to the top of the concrete slab, right? Now we need to add 80 millimeter. We would get this dimension, right? If I do that calculation, I will get the depth of the foundation wall. For basement, it's 2,300. That's how I get this 2,300. If I get the height of the foundation wall 2,300, I would take this height multiplied by the perimeter center line length, right? Understand that? Say perimeter center line length all the way around, right? This all the way around. Then I multiply by 2, I get both sides, right? Now you need to think about, if I do that, if I have, notch like this, right? Inside that formwork, it's shorter, outside is longer, right? We should subtract this area for the latch, right? So we need to take the height of the latch. I believe I gave to you 330. Take this dimension, multiply by the length. Now we need to think about, where is the length? That's here. That's the length, right? You get the area. That's what you need to subtract from a total volume of the formwork for concrete foundation wall. Other than that, you also should subtract those windows, right? Windows and the garage door, the check foundation wall for garage door, right? So if you look at the 3D drawing, that's what you need to subtract here for the formwork and concrete as well. Okay, formwork both sides. If you calculate concrete, you get the perimeter center line. Use the same perimeter center line. You multiply by thickness of the foundation wall, height of the foundation wall. You get the volume of the concrete, right? You also need to subtract those places. You see, you need to subtract volume of that. Formwork is we subtract the area, right? Area of this. Understand that, right? Formwork is subtract the area for both sides, right? That this situation would be only one side. This situation would be both sides. So now we need to think about this wall, right? How we calculate formwork for this foundation wall. So if I draw that, right, it would look like this based on the elevation drawing, right? So we know this dimension, and we can calculate this dimension, right? Take this dimension and add 200 millimeter. That's we want to get the foundation, concrete foundation wall. It's from there to there, right? That's a dimension we need to figure out, right? So we are going to think about, take that dimension, right? We multiply by the length. So the length would be this length here, right? From the foundation plan. We will be able to get this area here, right? This area. And of course, there is a recess on top of the foundation wall, which is for the garage doors here. We need to subtract this, right? Then step footing. Okay, step footing here, we need to add this, right? Formwork for this. I have the dimension here for you, just you can refer to that. We get the area of this, but we must think about this is for both sides. One side there, here, 1, 2, right? And another step footing, 1, 2, again, right? That's our extra formwork we need to add if we take the area of this. Okay, take the length here, right? So take the length here, foundation wall, right? Now let's look at the foundation wall. The height would be this, right? We will be able to get the formwork. Okay, formwork for this foundation wall. So if I want to calculate the concrete, similar, right? You already get the length here, you multiply by the height, you multiply by the thickness, right? Thickness here, you get a volume, right? But if you need to calculate the volume of the concrete, what is the best way for you to calculate here? Is, you see, take, concrete, right? For footing, you need to add this part. Okay, do more footing, add this volume of this. I gave you this dimension. For foundation wall, right? Concrete, you still consider the extra here, right? You have the area here, you multiply by thickness. you get a volume, right? Think about both sides for the foundation wall. Understand? That's concrete. Say formwork, both sides, concrete. You need just take the length multiplied by thickness multiplied by height, or take the area multiplied by the thickness. I get, I would get my volume, right? Understand that, right? Okay, that's this part. Formwork and concrete for this foundation wall. So now let me look at this foundation. Here, this foundation wall, if we look at the drawing like this, we need to visualize this if we draw a section, right? If we draw a section here, it would look like this. So this means the concrete slab goes on top of the foundation wall. You see this color? Means there's a large here. And this, this foundation wall will be shorter. Okay, this foundation wall is shorter. So that's look like this. So that means when we calculate the volume of this foundation wall of formwork, let's say formwork first. Formwork for this one foundation wall, the length would be this, right? The height would be this. You take 2300, you subtract 125 at top, you get the length of it, or height of this wall, sorry. The height of this wall, the length of this wall is this around, right? If you want to get very accurate information, you will realize this wall is slightly thicker. You may need to adjust that. Formwork is okay, concrete is a bit, you need to add a little bit here. Understand that? So that's how we calculate formwork. Take the length, multiply by this height, multiply by 2, right? Get the area for the formwork. Volume, you take the length again, right? Multiply by the thickness, multiply by the height, you get a volume for this wall, right? Okay, that is we look at formwork for foundation wall. So we talk about we need to subtract those where we have recess, right? And we need to subtract. But we also need to think about we add extra formwork if we have this kind of situation. Do you remember I talk about the my formwork for the edges in my PowerPoint presentation? I do have this, right? I said if we need to build this, there is a latch at the top, right? We need, when we calculate the formwork for this part, foundation wall, we subtract here, right? But we also need to add one piece there to form that notch. So some students say, Miss, why you separate them, right? You have, if you look at the area, why you subtract first, then you add another piece. The reason is because that's 2 steps. And, we price them differently. Think about when you install the formwork on site. You install the formwork this and this piece first, right? That's how you install the formwork. Later, you're going to install this piece. And this piece, the width of that foam is 125. And we measured by the length. When we price it by the length. You always need to think in this way. Everything we do on site, it costs money to do the work. So if we, think about, if we do this, separate this, on the site, it's first we do this, right? That there's a cost for that work, right? Later, we are going to do this piece. There's a cost there. And if you look at the productivity, it's different, right? That's why they have different unit price. That's why we need to measure this piece as well. So if I draw this piece, of the foam on the plan, it look like this, right? It look like that. That's a length. And when we I should say, we are going to how we build this foundation, walls, footings, and slab, right? We build a footing first, then we build this foundation wall, right? Build this foundation wall. Then we pour concrete of this slab after that. And we are going to, form this slab later. So we put a piece of foam underneath. That's a formwork for porch slab. And we don't need a formwork again for here because we already have a wall, right? But we need a piece of formwork here when we pour the concrete slab. And we need this piece of foam, which we build the foundation wall. Understand that? When we build this foundation wall, we need to build this foundation wall in this shape. We need a piece of foam here. And this formwork, only when we pour the concrete slab, we need this formwork. If I show this formwork under foundation plan, it look like this. The length would be like this, right? We would measure by the length. So we also need to think about here, we have a drop on the foundation wall, right? We put the two pieces of foam there, right, on the foundation wall. And for the slab, when we pour the concrete slab goes on top of the foundation wall. We have one piece of foam here. Same thing for when we have a basement window, and also when we have this concrete curb, right? We need to put two pieces of the foam at both sides. So if we add all the lengths together, that will be the quantity for item number 6. You see, formwork to interior curb, recessed edges, slant edges, who are under 200 millimeter high. How many meters? We add them together. That's the quantity for this. Number 7, you say formwork to recessed edges, 330 millimeter high. That's this. That's here. That's this. You say formwork, we need to put one piece here, right? The height is 330. The length would be this. Okay, that's this. That's item number 7. So item number 8, formwork to porch slab. We already mentioned that, right? That's this formwork, this piece of the formwork. This is how it looks like under section, that is under foundation plan. That's this area. Okay. That's formwork to beam pocket. You see, when we have steel beam, we need to build up beam pocket to hold the steel beam, right? We need to form that. We build a small wood box and put on top of the foundation wall before we pour the concrete slab. So how many beam pockets we have? Simply you can do the calculation, right? Each beam 2, right? 1, 2, 3, 4, 5, right? That's the quantity. Because if you look at this, that's each, right? We count. Form K-way, you see, what is the K-way? That is section here. That's this K-way here, right here. So that means the length of the foundation wall, center line length of the foundation wall, that is a total length for the K-way. So anchor bolts, right? You see, how many anchor bolts we need? And if you look at the loads, number 12 and 14, number 12 is related to the wood framing and for the foundation, basement foundation wall, right? It mentions anchor bolts. You see, anchor bolts 300 millimeter long, minimum, right? 100 millimeter in the concrete. The dimension is 12.7 millimeter diameter, right? That is for the sail plate. And you see, this is the size of 2x4 sill plate width. Okay, width 12.7 millimeter, which is a ½ inch diameter anchor bolts, and 300 millimeter long, and 1 millimeter minimum into the concrete foundation will add 2400 millimeter on center. So if we look at the bearing starts partition here, the same with the same anchor bolts here. So we know we are going to use anchor bolts to tie the sill plate to the concrete foundation wall, and also to tie the all plates to the concrete foundation wall or curb. So same thing apply to the garage. So where we have a garage door or garage foundation wall, we also need anchor bolts. And if we look at the porch, we don't need, right? Why? Because the porch slab, where is that? See, you see, if we have a porch, that's a porch slab. On top, we don't have wood framing, right? That's why we don't have anchor bolts for this wall. So after we understand that, right, we would take the length, right, total length of this perimeter center line of the basement foundation wall plus the length of this wall. We do have that dimension when we calculate the formwork and concrete, right? So we take those lengths, add them together, add this length, right? And take that length divided by 2400 millimeter on center, we get how many? But we need to pay attention to at each corner, we always have, at a corner, we always have one anchor bolt this side, another one anchor bolt this side, right, at the ends. So each corner we add extra one anchor bolt. Every corner we add extra one anchor bolt, okay? And also say we have, if the foundation wall has an open end like this, every open end we also add one extra anchor bolt. For example, this, you see, this piece of the wood framing wall, right? The length is only 985. We still need two anchor bolts. Think about the spacing is 2400, 2.4 meters. That's a spacing of the anchor bolts, right? If we take the total length divided by that spacing, we don't have enough for this kind of situation, right? So what do we say? Each open end, we also add one extra anchor bolts in our estimate. That will give us enough anchor bolts. Okay, understand? So each corner, each open end, we add one anchor bolts extra. So that's anchor bolts. Contour joints, right? We measured by how many meters by length. First, we need to understand where we have this contour joints. Let's look at the section. Here. You see, normally between the foundation wall, we just look at this. Between the foundation wall and concrete slab, we have a contour joints. Sometimes we also call that expansion joints, to allow the foundation footing and the slab have different segment because the load, right? This foundation wall, foundation footing have bigger load compared with greater load, compared with the load on the slab. If you think about the way you push the soil, right? The harder you push it, and the soil will settle more. That's why we need that contour joints or expansion joints to allow a movement, different movement between the foundation footing and the foundation wall, foundation footing, and the concrete slab. If we understand this, that means if we calculate the length of this control joints, that would be the perimeter of this concrete slab, the edge, right? The edge and the perimeter of a concrete slab, or the perimeter of the inside of the foundation wall. So if we look at the foundation plan, right? If we look at the foundation plan, that means we calculate the perimeter of this, say inside the surface of the foundation wall or edge of the concrete slab. That's our perimeter. Okay. And we also need to think about in the coat sealer, we have same situation, right? In the garage, we have the same situation, but if we have a concrete slab which goes on top of the foundation wall, we cannot have a control joints there. That's why we take the total length. We need to subtract the width of the garage door. That's how we get the total length for the control joints. This item 12, 10 millimeter thick control joints between concrete slab and wall. So concrete, same idea, right? If you know how to calculate the formwork, I believe you should know how to calculate the concrete. The rebars. If we look at the rebars, in the grade beam, you see, if you check this grade beam detail, see, there are 4 10M rebars in this grade beam. So that means we can take the length of the grade beam, we multiply by 4, we get how many, right? After we get, we get how, what is the total length, not how many. 4 is how many, right? We get how many, 4 of them, the length of the beam, multiply, 4 multiplied by length of the beam, we get a total length, then we convert it to how many kilogram. That's how we think, right? You see, that's how we think about that, right? And I gave you a look, and you can refer to my, help sketch. And we also have this rebars when we have coat sealer slab. You see, my assumption is 10M rebars at 300 millimeter on center, both way. If we draw that as every 300 millimeter this way and every 300 millimeter that way, right? That's where we have rebars. I said let's use 50 millimeter as a concrete cover. So you take this dimension. If you want to get the length of this rebar, you take this dimension, you subtract 50 millimeter concrete cover this side, right? Another side you don't really need, right? Another side, because it is, because there's a, this outside, right? Another side you do have concrete there as well for the foundation wall. So you take this dimension, you subtract 50, you get the length of each. And then you figure out how many, right? Take another dimension, divide by 300 millimeter, add 1 at the end, right? You get how many? Same thing for this rebar. So dowel, you see, 10M dowels, 400 by 400 millimeter at 600 millimeter on center, around perimeter. So that's a dowel. So we can figure out the length of each, 400 millimeter plus 400 millimeter. That's length of each is 800 millimeter. How it lay out every 600 millimeter around here, right? You take this dimension, you divide by 600 millimeter, you will get how many, right? Take the length of each, multiply by how many, you get total length, right? Then you convert to how many kilogram, same idea. We also have rebars here, see. 3 20M rebars here, right? You take the length of this, multiply by 3, right? Get total length. Then you know convert to how many kilogram. I think I have assumption on the length on my on my requirements. Refer to that. You should be able to get the quantities for the rebars for this project number 1. I think that's all I want to talk in this video.